Permission request. Hello.
Hello.
On the behalf of SSBT COT Bambhori Jalgaon, I heartily welcome Dr. MP Singh.
Thank you, sir.
All the participants.
Am I audible to you, sir?
Yes, sir. Yes, sir.
Okay.
So welcome in the second session, all the participants. Now, today's speaker in the second session is Dr. MP Singh. So let me introduce Dr. MP Singh. Dr. MP Singh, working as an associate professor at CSE department in NIT Patna. Dr. Singh did his PhD from MNIT Allahabad. He has published many papers in the national and international reputed journals. He has guided 9 PhD scholars also. He is the professional body members of some societies like IEEE, ACE, etc. He has developed various labs in the institute. He has organized many national and international conferences and FDP also. He has delivered expert lectures in various universities and colleges. He is a PhD supervisor. He is a research of interest. The area of interest and the research interest areas are data networks, wireless sensor networks, machine learning, security, etc. Now, I request Dr. MP Singh to start the session on the topic Generative Adversarial Networks and its application. So, I welcome Dr. MP Singh and I humbly request Dr. MP Singh to continue the session. Please welcome, sir.
Thank you. Thank you very much for giving me opportunity to, I will not say that I'm going to deliver the expert lecture, whether we'll have the sort of knowledge sharing with the other part of the audience. And I will try to disseminate the knowledge, in fact, the basic knowledge as well as some advanced knowledge of generative adversarial network, which is basically a part of machine learning. Aim of this presentation would be targeting the audience would be starting from the basic and then We'll see what we can do with the GAN network and what are the challenges that we have. Parallelly, in order to convince, I will try to explain the some of the twice example as well as the some of the very good applications of the GAN network. So let me share the slide and so the slide is visible to all of you.
Yes,
Can you
sir.
read it? Hello.
Yes, sir.
Okay, okay. Thank you very much for confirming. So as I was telling you that the aim of this session is basically to discuss with this new topic. It's not new for the researcher, but could be new for the many of you. The generative adversarial network, but the name itself does not give any clue whether this is the part of the machine learning or not. So while discussing this generative adversarial network, we can realize that this is basically a core machine learning algorithm where we do the certain different kind of activity as per the requirement of our research in the machine learning. So overview of this session is we will try to understand why do we need this generative adversarial network, because before this concept, we had the many other methodology or concept to do the many similar things. Then the obvious question is, why do we need this generative adversarial network? And then I will be introducing this. Then we will try to understand what it does. The very simple algorithm, let me tell you that the researchers has worked a lot in this area since 10 years, and they have given the many different algorithm, but I will be talking the simplest algorithm, and that could build a basis for the advanced learning of this GAN algorithm. Parallelly, we will discuss the difficulties with this network so that we can find out some of the interesting research problem to work upon. Then evaluation matrices, since we are doing something, we are having the certain kind of architecture related to the GAN. So obviously we have to measure, we have to evaluate our model. So for that we have the different matrices. But in my lecture, could be more than 20 different matrices that we are using to evaluate the GAN model. But I will be talking very two basic the matrices, because it may not be possible to cover all the evaluation matrices. Then how can we do some variations in the GAN network, followed by the applications? And especially I will be talking one application in the security and one is in the medical imaging. Then what we can do with this network in future. Then finally I will conclude my session. I will start my, as you, all of you must be aware of this government of India, including every other government, they are giving the more emphasis on the artificial intelligence. And now almost all the IT industry, they have the separate artificial intelligence wing to work upon. So this is Ian Lynching, director of Facebook Artificial Intelligence Unit. His statement is, generative adversarial network is the most interesting idea in the last 10 years in machine learning. And that is what we are going to, maybe we will be realizing after the concluding of this session. Now, so very first thing is, because you may not be knowing about the GAN network, but you must be knowing the sum of the previous model, and that model normally we call it as the generative model. The name itself will suggest you that we want to generate something. The dictionary meaning, the generative is what we want to generate something. The moment we say that we want to generate something for the machine learning, so as I can see the schedule, you must be having the fundamental knowledge about the different processes of or different algorithms for the learning, and where the data set is very much important. But generative is what, again, we are trying to generate the data set. We will see what is the importance of generating the different data set.
Sir, sorry to interrupt you. Sir, can you just zoom the slides because it is not visible?
I have
The
zoomed
diagram. Is it for me only? Like I can't see the diagram properly.
I have not shown any diagram right now. It is a simple PPT, the text PPT.
Yes, sir, I can see, but there is one diagram like taxonomy of generative models, but that is not zoom. I can't see.
Now is it visible?
Sir, nothing is visible now. Only window is coming.
Let me start again. I will close this.
Yes, sir. Thank you.
But somebody said that it is visible.
I think that is the second slide which she is telling. It's the first one only we are seeing it. The second one which is shown on the this as a small thing, that's what she's talking about.
Well, there is a diagram that is not like visible.
Yeah, no, that is the second slide, I think, Shweta.
Oh, okay, sir. Okay.
Yeah.
Is it visible now?
Yes, sir. It's visible
Yes,
now.
sir. Clearly visible.
It's okay?
Yeah, it's fine. It's fine.
Okay, thank you. So I was just talking about the need of this network, because before this we had a different kind of model to generate the certain data specific to the some applications, maybe then NLP, natural language processing, maybe for the image processing, maybe for the data medical imaging, and so on. So as per the requirements, we had very old different models where we do the same thing to generate the data. So we will start with let's say the autoencoder. It's one model which basically tries to do something, but we do not use or it may not be suitable for the many applications. The reason is the very poor result. In case of the image generation, the output of autoencoder, the very poor result in terms of the quality of the image, in terms of the different features of the image, and so on. And what was the reason for the poor result? Basically, we try to minimize the distance to produce the blurry prediction because of the averaging. We all know that, especially in case of the image processing, we need not to have the knowledge about the image processing or the. Hello. बाद में बात करो. So sorry. So a very simple process was the smoothing filter. So a smoothing filter basically what it tries to reduce the noise and blurry the operation. How it does? It takes into account the pixels surrounding it in order to make a determination of a more accurate version of the pixels. In this process, what could be possibility that we may not be getting the very good results or the good quality images at the output. So with the various different generative model, we had the different issues related to the output. And that was the basically a reason to find out the some another model where we can generate the output as per the requirement of our applications. So in the previous model, before the GAN, whatever the image, especially I'm talking about the image, but this is applicable to the any domain. You can think of the natural language processing, you can think of the computer vision, you can think of the security related output and so on. We will discuss some of the applications if the time permits. So it was very easy to, from the naked eye, we were able to distinguish the output of the model before the GAN. Means you can easily predict, you can easily say that whether it is being produced from the some model or it is the real pictures and so on. But our requirement is what? We want to produce the image which looks like a real. Though we will name it as a fake because our model is producing the image. So we will call it as, for the namesake, we will call it as the fake image. But the fake image could be, it looks like a real, means it could be very difficult to distinguish from the real image. That kind of quality we wanted in case of the many image processing applications. Another reason to have this GAN network is, there are many domains where we are facing a very serious problem, the missing and the incomplete data. Missing data means what? Out of available data, as I told you that you must have gone through some of the learning process of the machine learning where you understand the importance of the data set. But there are many situations where data set must be having some missing data. Like in one table, you have the, let's say, 10 attributes. Out of 10 attributes, one attribute's value is missing. The reason for missing the data is numerics. I'm not going to discuss what are the different reasons. Especially, this problem becomes the very, very serious problem in case of the medical domain. I will tell you some of the reason why. Because until unless you understand this reason, you cannot realize the importance of the GAN network. Okay, so in medical domain, this problem becomes the much more serious. Reason is the data is not being shared. Let's say if you want to do certain kind of the machine learning on data set, especially for the cancer patients. So you know that one is what? The hospitals, they do not share the data with you, the real data. Could be the many reasons. Could be that the privacy of the data, the patient privacy of the data. Could be there's some legal issue also. I will tell you the one fact where due to just medical errors, the 10 of thousands of deaths every year in US. It's a very, very serious. In India, we don't have such data. So I have taken this data from some resources, which I am sharing with you. The medical errors means during the treatment, there could be many lapses. Don't think that we have this the lapses in India only. This is across the country. So in US, there are the 10 of thousands, the date of every year, which is much more than the combined sum of death due to road accident and the cancer and the AIDS, which is much more. Why? Because there is some lapses during the treatment. Now, if that hospital will share the data, you will analyze the data, you will pinpoint what are the lapses done by the doctors, then by the hospital management and so on. So there will be a legal issue also. So just because of these legal issues, hospitals do not share the data with you. So ultimately is what? We don't have the sufficient data to do the analysis. Now you will think, why do I need the data, especially for the cancer or maybe the some critical disease also? So you realize that in many cases, we want to do the certain kind of analysis to learn from the previous history, from the history, and then we want to correct our systems for further. So in that way, we need the data, and which is not available. One more reason, there are very rare diseases that are maybe in the lakh across the country, but for that rare disease itself, you don't have sufficient data to learn, especially you cannot make your machine to learn with some insufficient data. So, for example, in cancer, many of must be knowing that the PET scan, the very rare PET scanning is being done. In fact, in Bombay, the Tata hospitals, if you'll go, out of every 1,000 or 10,000, so only I think 100 patients are going through the PET scan. Means you don't have the sufficient data for the PET scan. So how can you do the machine learning process on that very small data set? You need to have the certain data set. There are some situations where you have the data, let's say the CT scan you have, but for the same disease, you don't have the MRI scan. But you know that from the MRI, I can get the much more better information. It will help you to diagnose the disease in much better way and so on. So what you want to do? You will not sit idle and look for the MRI data until unless I get the MRI data, I cannot do further and so on. So there is an option that the researcher has thought of, why not from the existing image, can we generate some fake images which looks like a real image? It means, I mean to say, from the CT image, can we generate the MRI image? I'm just throwing this question. I'm not answering this question. So with these all questions, researchers have started the new concept. This is not very new, but the 10 years old only, the generative adversarial network. Now, as I was telling you, before this GAN, we had a different models. I will not give much time on this because many things I need to talk about the GAN. Here, just to convince you that there were the many models, the taxonomy of the generative models, starting from the maximum likelihood. Under that, we have explicit, because in all this we are using basically a density function, the probability density function, either explicitly or implicitly. So with this, we have the different model to generate our data set. For example, here, just to make you understand what we can do with the maximum likelihood. With this graph, before going into detail, let me tell one thing is, I have taken the many slides or the figure from the different sources. So with all, I want to acknowledge all the resources in my slides. So what is that here is, in this graph, if you look at length of time in second that it takes a student to answer the specific exam questions. Okay. Now, if you want to understand the maximum likelihood with this, so what we can do is, you can think of, because we have to understand what is the distribution of this point. So you can think of, with this data points, we want to model where we want to use the some distribution, some model for distributing the data points. And this data points is only will help you to think of to frame our model. So you can think of the Gaussian, where basically we are using the two different parameters, the mean and the standard deviation. The different value for mean and the standard deviation, you may get the different curve. Now here, it's our job, because we want to model our data points. So our job is what? To find out some specific value for mean and standard deviation where our data points will be represented clearly. This is what the maximum likelihood concept. Now in the generative model, as I told you that aim is to the model the distribution of a given data set. For generative model, data set, usually we are using images, but this is not restricted to the images. Could be anything like the audio sample, could be the time series sample, and so on. Now, in case of the explicit generative model, as I told you that in all the models, we have to think of the some probability density function. So in the explicit generative model, the probability density, it is in your hand. You know that which probability density functions we are using. Explicitly, you are mentioning that. Whereas in case of the implicit generative model, from the distribution, we have to find out which means we have to model the probability density. That is the basic difference between the explicit and the implicit generative model. Now, broadly, we can categorize all the generative models maybe into autoaggressive, reversible, Bayesian autoencoder, and the generative adversarial network. In case of autoregressive model, we generate the image using, means if you have the one pixel, so after that you may generate the another pixel. So pixel by pixel generation is there in case of the autoregressive model. In case of the reversible model, you can generate the image from the noise, and the from noise to image can also be generated. That's why it is the reversible model. The Bayesian autoencoder, it consists of the many different networks. Network means what? You don't think of your computer networks and other networks. Here network is what? The ANN. Could be the deep neural network, could be the artificial neural network. Okay, so network, whenever I mean to this neural network, different types of the neural network, and very specific to the deep neural network. So with this Bayesian autoencoder, we basically distinguish by having the continuous latent space. I hope you understand the latent space. And the last one is the generative modeling. Now, we will understand, we will stick to our GAN network. As I told you, this network means the kind of deep neural network specifically we are using in the GAN network. In that, we have the two different kind of the network. One is generative network, another is discriminator network. The name itself will, you can easily point that what we do with these two networks. Generative networks means what? It will generate the data set, the new data set. Discriminator is what? It is kind of a classifier which will classify whether the data given to discriminator network is real or fake. This is the job of these two networks. Okay. Now, if we look at very carefully, we can think with respect to the optimization problem of the GAN. We will see how we can say this is the optimization problem. Now, another term in this GAN is what? The adversarial. Adversarial means they do not support, means the both network, the generative and the discriminator network, they both network does not support to each other. The generator is basically trying to fool the discriminator. How they can fool the discriminator? It will fool because you know that generator will take the input as some noise input, and from the noise input it will generate the some image. Now this image will be taken by becomes the input for the discriminator. Now the discriminator job is to what? To classify whether the image which the discriminator has received is real or fake. So generator is trying to generate the image, looks like a real image, and it will try to fool the discriminator so that the discriminator itself will accept the image as a real image. Though it is fake image, but discriminator will accept as a real image, and that is what generator will try to make the fool discriminator. Whereas discriminator is consistently trying to categorize the images in proper class. Here we will consider the only two class, the real class and the fake class. So the generator output, it will try to predict as a fake image. So both are fighting to each other. Fine. That's why we call it as the adversarial. In this process, because the first time, you think of the first iteration from the noise, generator has generated the some image. Do you think that that image could be a real image in the first iteration itself? If in the first iteration itself, if we are getting the real image, means image like a real image, then there is no part of the training. But as you know that without training, these two networks cannot do the job. Since this in the both networks we are using the deep neural network, so there is a process to train the both networks separately. And while learning, once I have learned, let's say generator has learned, then there is a chance that discriminator will accept the fake image as a real image. That means generator has made the fool the discriminator, and the so on. Okay, so in this you can see that the both networks are opposing each other, and that is the reason we call it as the adversarial. Now, in this slide, we are just looking at very, very simple architecture. The very just a scan from left to right. The very first symbolized as Z. Z is basically the noise points, the random noise vector. G is generator. Now, if you look, the D is basically a stand for the discriminator. In the D, we have the two different inputs. One input is the output of the generator. Another input is the real as images. If we would like to understand in terms of the images, so Z is what? You have the one image. From that image, randomly you have selected the the vector from the image, and that you have given to the generator. Generator has generated the some image, and that we will name it as a fake. So fake image and real image, both part will be given to the discriminator. Now discriminator, as I told you, its job is to classify into real or fake image. Yeah, so we will understand first the generator. As I told you, the generator is nothing but it's a network, the deep neural network. So what we do, we give the just a simple, or we call it as the noise. Randomly you can take the, in case of the images, randomly you are taking the some vector, image vector, giving it to the generator. That vectors we can call it as the latent vector also. Means it is hidden, but is very much important for the image generation. So the certain, now we have to see that if I take the same vector every time, so there could be a possibility that generator will generate the same images. And if the generator is generating the same images, then discriminator will be able to find out whether it is real, or means generator is giving a chance to discriminator to classify as a fake image. So what we do is we take the some random noise. Okay, we take the random so that it will generate the non-deterministic output, and that becomes the difficult for the discriminator. Okay. Now, discriminator, as I told you, it's a kind of classifier, classifying the images. The both inputs classified in real or the fake image. So discriminator outputs a single probability like the 0. 0 means what? The fake image, and the 1 is like a real images. Now, the very old problems you must have gone through in the game theory and artificial intelligence as well. The two-player min-max game. It is basically the algorithm where we try to understand the Nash equilibrium. Are you aware of Nash equilibrium, or shall I tell you something about the Nash equilibrium? Otherwise, we can save some time to discuss something else.
So
No, sir,
please
not
tell, we haven't heard about it.
Okay, okay. So what happens is, I will not give you the typical definition of the Nash equilibrium. Nash is basically one scientist who has given this concept. And equilibrium, you understand the dictionary meaning of the equilibrium. Now try to understand with the help of one example. I'm quoting it. Let's say in game, the min max is what? It's a kind of the two-player name. Main is the one player, max is the one player. So these two players has, let's say, taken a strategy that whenever it will take a path A, it will receive, let's say, the 1 rupees. Otherwise, it will take the path B, it will lose the 1 rupees. This is the game. Okay? Path or strategy in game. So wherever there is a game, there is a strategy. Okay? So if you are choosing the strategy A, then you are basically winning 1 rupees. If you are taking the strategy, another strategy, then you are losing the 1 rupees. So what this both player will do? The both player will try to choose the strategy A because everybody wants to win the game. And ultimately they will receive the ₹1. If you will reveal, let's say, the max strategy to mean, max is having its own strategy to play again. Mean is also having the strategy to play again. So let's say if we are revealing the max strategy to means or vice versa, then you can see that the no player will deviate from the original choice because both are aware of the strategy. So knowing the other player moves means does not change either player's behavior. And the outcome, basically this outcome will represent a Nash equilibrium. Let me give you some more better example. Let's say the two company A and B both wants to launch a product, and for that they want to advertise. Now, if both companies start advertising, each company will attract the, let's say, the 100 new customers. If only one company decides to advertise, then that company will attract, let's say, the 200 new customers, while other company will not attract any new customers. So if the both companies decide not to advertise, then no company will get any new customers. So what is the payoff? Payoff will be the company A should advertise its product because the strategy provides a better payoff than the option of not advertising. So two strategy, either advertise, not advertise. So where it will get the better benefit? So in advertisement. The same situation occurs for the company B also. So this is what? This is basically an equilibrium situation. And since this situation was modeled by the Nash, so we call it as the Nash equilibrium. And that is what the mini-max, so both are fighting to each other to get its own benefit. Okay? So that is what we are using in the GAN network aspect. Now, please look this slide very carefully, and then I will discuss what we are trying to do. Here I wanted to convince you that what we can do with the GAN network. This MNIST is basically, it's a data set, the data set collection of the 110 digit number. Now from the blur, here, one image, it is continuously running. The one image is a very blur. You cannot see any digit. Now that you can consider as the noise data given to the generator. Now over the time means over the iteration, over the different epochs, maybe the 40, 50 different, depends on the kind of the input that we have given. The networks will learn, and finally it will give you the very clear picture of the digits. Okay, so this is one of the GAN network work that we want to get it done. Another fantasy, or you can see that by example, but example is toy, but the process or the model is very complex. What we are trying to do, the very first figure, left upper part, from zebra, we can generate the horses. Means the input we have given the zebra, and the output we are creating the horses. From the horses, we can create the zebra. Right side, the daylight pictures you can convert into the night pictures. This all can be done with the different kind of the model of the GAN. Okay, here just I wanted to convince you what we can do with the GAN network. Once we will understand this, then we can see that how we can design our own model for the GAN network. So GAN is basically we just think of the different component we have understood, and now it's your turn to design the model as per the requirement of the application. Like here, what we are doing, as I told you that without training in one epoch, here in this figure, do you think that in one epoch we can get a correct output or correct images? No. So after the different epoch means we are giving the training to the both network of the GAN. Okay. Now, so from the latent space, we are mixing with the noises. As I told you that the different variable noise, if you give, then we can generate the non-deterministic output. Otherwise, same output will be generated, and that becomes very simple for discriminator to learn that whether it is fake image or the real image. Now here, so after mixing with the noise that given to the generator has generated the fake samples, fake images. Now that fake images will become the input for the discriminator. Now discriminator will also receive the real images. You look at the real sample, the upper part, it is written real sample. Now from that, the both part is being given to the discriminator. That means what? Discriminator has a chance to learn the real image and fake image. Okay. So based on this learning process, discriminator is able to distinguish whether it is real or fake. Now, the fake, just consider the one fake sample is being given to the discriminator, and discriminator is identify it is fake image. It is correct. So this is the winning situation for the discriminator. But this is the loss situation for the generator. Okay. Now, this feedback, the output of the discriminator will be given back to the discriminator as well as to generator. We will see the both component cannot get the training at the same time or in parallel. No, they both get the training in the different phases. Okay, though it is being shown here, but based on the output that we give the feedback, means you can consider as a back propagation. Through the back propagation, discriminator will also learn. It will do the fine tuning to give the more accurate result. Similarly, generator will understand that, okay, whatever the image is being generated right now, it has been classified correctly. So I need to generate the more something. We have to do the something more to generate the image looks like a real image. Okay. Now, we have to understand the training part of the board. So if you look at here, the first, we can give the back propagation, whatever the output of the discriminator, we can give to the discriminator separately and the generator separately. In fact, whenever you are giving a training to discriminator, at that time, generator will not get any training. Training means what? If you have the very little knowledge about neural network, I'm just saying the neural network, I'm not classifying neural network as a CNN or DNN and so on. So in neural network, you know that based on the output that we got and the kind of error that we have calculated at the output, we want to minimize the error rate. For that, we are basically updating the different weights of the neurons. And then again, the next iteration we go and so on. So we are basically updating the weight of the neurons to give the more accurate output. That is what the very simple concept in the neural network. So here also we are doing the same thing. So in the generator, if you look at the input we have given, some noise. There is a generator, another type of the generator. We call it as the conditional gap. Means some conditions we are giving explicitly. It is not necessary to give the condition also. Okay. So without condition also we can think the input as a sample noise and whatever the images it has got, and that images is been given to the discriminator. Now discriminator predicts the input as a 1 means the real image, 0 means the fake image. Now what this generator will do now? So train the G to push prediction to 1. Did you understand what is the meaning is? Meaning is we have to give a sufficient training to the generator so that the output of discriminator should be 1. Should be 1 means what? The fake image will be considered as a real image by the discriminator, by the classifier. And that will be the achievement of the generator. So we are giving the input, means the training phase. We give the sufficient information to change the gradient, change the weights of the network. Which network? The generative network, so that it will produce the improved images. Again, it will give it to the D. Let's say D is again able to predict it correctly as a fake image. Now again the input has been given to the generator that okay, like this time also your image has been categorized as the fake image. So again generator will learn something, will tune the weights and all, it will generate the next image. After the many epochs, there is a chance that the output of generator will be classified as a 1. 1 means though it is fake image. Let me tell you very clearly, the output of generator will always named as a fake. But we want to fool the discriminator so the discriminator can classify the fake image as a real image. Reason is what? The generator has produced the image which looks like a real image, which cannot be distinguished at least by the human eye. Okay, there could be some technology where we can the simplest one, the pixel by pixel, the different property of the images we will catch and compare it. There could be a possibility to categorize it, but that process will take the huge amount of time. Okay, and in many applications we don't have that much time, so time is also important, right? So this is what we do with the generator. Now, in case of the discriminator learns from the both input, because the two different inputs is being given to the discriminator. In this figure, if you look at only one discriminator we have, but it is being shown separately. That one input is fake image, another input is real image. So with both, it learns. It learns, sir, that, yeah.
Excuse me, sir. Sir, I am unable to understand what is the significance if it is generating a fake image generator and the discriminator is just discriminating the good one or the true one and the false one. Then what is the significance of doing all?
Question. But can you hold for the 2 minutes, because next slides will be talking about that. Okay.
Okay.
Fine. Thank you. So let me. You think of that one participant has asked a question about the significance. Means the generator output is the fake image, then what is the means we are saying if it is the fake image, then what is the importance of having the such kind of the model? Okay, so we will understand this question with the help of I have the 2-3 slides taken by some resources. I will make you understand very clearly. Before that, you try to understand this. Here in the first graph, if you look at the blue line is basically is the discriminator output. Data has been given, the discriminator has given this representation. Now our actual data distribution is the black one. And now model is distribution is this. Z is basically the noise, Z representing the noise, and X is nothing but your real image. So here the model is very poorly fitted. Now the training has been done, something has been updated in the discriminator. So now you can look at this. The output of discriminator blue line has got some different shape. Through the graph, I would like to make you understand that. Now, after the generator has got the training, so now if I look at the data distribution and the model distribution, both are very close to each other. And finally, whenever we have reached to some equilibrium state, so you will see the model is this data distribution and model distribution has aligned, and it becomes at this stage it becomes very difficult to distinguish the real image and the fake image for the discriminator. Okay. Now here it's very important to understand this the simple version of the algorithm of the GAN network. The first for loop here and the second one. What we do, this is for basically a discriminator. I will make you understand this equation because it is important to understand this equation. Here, the discriminator, as you have seen the figure of discriminator, it will get the output from the generator also and the real image. The two different input has been given to the discriminator. Okay. So now this is noise, some sample noise you have taken, which is being represented as a vector in terms of Z1, Z2, Zn, and the real it is being taken as a vector X1, X2, X1, so on. Now, the data generator distribution, what it is being done in this equation, you will look at the two different portions. The first portion log d x and second portion log 1 minus d g of z I and so on. I is what? It's basically the vector, means the summation. That's why we are using the summation here 1 to n. Now you understand the first portion log d. Log you understand for the you understand the logarithmic where we do the logarithmic. So it is not important to understand the log. It is important to understand that this. So discriminator d is not. It is basically the output of the discriminator when we are giving the real image. Fine. Now here come to this. The Z, as I told you, it's a noise. This is being given to the generator. So this becomes the output of the generator. Now that is being given to the discriminator. So what is the probability that discriminator will identify the input given by the generator as a 0 or 1? So this is the basically a whole understanding of this algorithm. This equation. Now look at very carefully. As I told you that here the GAN is basically the kind of mass equilibrium we are using minimax player. So one is trying to minimize the value of this equation, another is maximize that. So generator tries to minimize the value and discriminator tries to maximize this value. Now the log ds, as I told you, that it is calculated with respect to the training data sample. Okay, which training data sample? The real training data sample X. Okay. Now here, as I told you that this portion is output of the discriminator, the complete. This G of Z is output of the generator. D of G of Z is basically output of the discriminator when generator images are given as an input. Fine. Now, so what is this? The dx is basically, it's estimating of the probability that real instance x is real, the first one. And ex is what? Expected value over the all real data instances. Similarly, in case of the second portion of the equation. Now, here, as we have understood, the two different networks we are using. One is generative, another is discriminative. Generative mode, if you compare these two, by understanding the some text content, you will realize the generative model is much harder compared to the discriminator. We'll tell you the reason. Mathematically, you try to understand. You look at here, the first portion in this image is the discriminator model, another is the generative model. Discriminator model is what? It looks like a conditional probability. Means label is being given. Based on label, whatever the input x is basically your input given. Now you want to label whether this input belongs to y is equal to 0 or y is equal to 1. So what is the job of this model? Mathematically, job of this model is to draw a line in the sample space to classify the samples as a real or fake, as a y is equal to 0, as a y is equal to 1. So this job is very simple. Now come to the generative model. Generative model, what is being done? It is kind of the joint probability. Means on the sample space, the input is been given, and from the sample space you have to see whether you have generated the image that can be categorized as a fake or the image that is fake, but it cannot be distinguished by the discriminative model. So in the data sample space, we have to find out the category. Yeah, yourself we have to find out. So this joint probability is much more difficult than this classifier. Okay. Now the questions to that the answer to that question, the ask right now, somebody asked that. Now look at this. This has been taken from some sources. It is not my slide. Now, look at the three things: the generated, discriminator, and the real data. Now, here, if we look at very carefully, the first time, generator has taken some noise data and it has generated this image, the very first image. Now, discriminator has it has got the training about the real image or the fake image. What is the real image? Especially in this case, example has been taken of the currency, dollar currency. So discriminator means classifier is well aware of the real currency, means what looks like, what are the property of this images of the real dollar currency. Okay. So when the first time generator has generated this data, so this becomes very easy for discriminator to say that this is fake image because it has learned that what is the real image, what looks like a real image. But now the training is going on. Some input has been given to the discriminator, some input has been given to the generator. Now generator, it's a network. It will fine tune the weight and all, and now it will generate the next data. Next data is this, where 10 is retained and some emoji has been generated. Different data it has generated. But now again, discriminator is able to distinguish that the generated data is fake one, because it knows that what is real and what is fake, the discriminator. Now, over the time, now this process is continuous. The training is going on. Every time you have through the back propagation, we are fine-tuning the weights of the neurons of the generator. And finally, the generator has very clearly, look at this, generator has generated this image because it has learned during the training. So after maybe the 40-50 epochs, the generator has generated this image. Now, generator knows that this image is fake image. But the discriminator is not able to distinguish from the real image. Though it is not real, but discriminator has categorized as a real image. Okay, so that is what now this can be understood with the help of the some applications requirement as well. So here you can see that the generator has generated a data set which looks like a real. Now, the beginning of this session, I was talking about the missing data, incomplete data, and so on. I was giving you some example, especially in case of the medical domain, where we don't have the sufficient data to do the analysis or to apply the different learning techniques of the machine learning. Okay, so then what you want? You don't have data. There are various reasons. Even though data is available to some agency, it is not available to you because of the many legal issues. One, the most important is the data privacy. Another importance that I shared the data of the US hospitals and so on. So due to the legal problems, you don't have the data set. So are you trying to shift simple ideal, not doing anything? No, researchers are not ready. So what the researchers are doing, they have modeled its own GAN structure to generate some data set which looks like a real, which can be used to do the analysis of some particular application, some particular application. Now, here we have to look at in one goal, the complete component of your GAN network, some random input generator has generated some fake sample, real images given to the discriminator. Now, discriminator output can be classified as a loss. Here, you remember I told you that kind of the optimization problem also we have to look at into the GAN. This is what the optimization that we have to look at. There are two different kind of the loss, discriminator loss and generator loss. What could be the discriminator loss? If the discriminator is classifying the fake image as a real image, then it's loss. It's because the discriminator job is to what? Discriminator job is to classify the real image as a real, fake image as a fake. But we have understood that over the time, this network can learn and discriminator will not be able to distinguish between the real and the fake image. So that we can consider as a discriminator loss. Whereas, what is the generator loss? If the discriminator is able to classify the fake images as a fake images, then it is the generator loss, because generator wants to make full discriminator. Okay, so these two losses we have to it's a kind of the optimization that we want to, generator wants to increase the discriminator loss, generator wants to decrease the generator loss, whereas discriminator wants to decrease the discriminator loss, whereas it wants to increase the generator loss. So both are fighting. So, but this model, after learning, this model will be in the equilibrium state where we can think of the optimization problem of these two losses. Okay, now look at this, what we do in case of the training, especially in case of the back propagation. So the first is the discriminator. So let's say there is a loss. Loss is being calculated. Now with this loss, this information will be given back to the discriminator. Discriminator will learn something. It will improve its own weight and all. It will do some kind of the changes in the neuron weights, and now it will try to decrease the discriminator loss and so on. If you remember the simple neural network architecture, we ultimately were calculating the error rate and so on. So something like this one. Now, while updating the neuron weights of the discriminator network, there is no update on the generator network. There is no update on the generator. Okay. Now, whereas in case of the generator, if you'll see, in case of the back propagation, from the generator loss, this information has to go back to the generator so that it can do the fine tuning of the weights and finally will try to improve its output. But this generator loss information has to go through the discriminator. But it doesn't mean that it will change the weight of the discriminator network. No, there will be no change on the discriminator network, but because this is the architecture, it has to pass through the discriminator, reach to the generator. Generator will do the fine tuning with the weights and will learn something to improve its output. Now, with this approach, there are certain difficulties also. Non-convergence. It's very difficult to converge at a single point because both are adversarial, though both are fighting to each other, and there could be a possibility to not getting the convergence is the one model, because we are using the two different network here. If the one network is much more powerful than because it is your design, that you have to think of that what kind of network you will be using. You have to think of your own network, the neural network, the deep neural network and the convolutional neural network. So architecture of that. So if the discriminator network is much more powerful than the generator, then it becomes difficult for the convergence. So any one of them is powerful than others, then it is difficult to get the convergence. Another problem is estimating the uncertainty. Okay, this is I will not give the much time on the uncertainty. Here it is important, the mode collapse. Mode collapse means what? Dictionary meaning, if you look at the collapse, it is kind of that the both models are not able to work properly. Now question is, how do we get this collapse? Now you know that the both network is basically trying to improve their work. How? Generator improves with training. Discriminator performance gets worse because the discriminator cannot easily tell the difference between real and fake. With one example, we understood that. Because one time will come where the generator has learned many things and now it is generating an image which looks like a real image. So what is the difficulty for the discriminator? The discriminator will not be able to classify easily. I am saying easily. Okay. A still discriminator can do the classification depending on the kind of architecture we are using of the DNA or the CNV. So if the generator, now I am saying if generator is classifying perfectly, generator succeeds perfectly, then discriminator has 50% accuracy. Why 50% accuracy? Only real image will be classified as a real and all fake image will be classified as a real, because now the kind of image is being generated by generator has learned all the things. Now it can generate the image looks like a real image. So accuracy of the discriminator is now what? We can say it looks like a 50%. So now in this situation, what is the choice of the discriminator? Now discriminator does not know anything what to do. So it will randomly will say that whether this is real image or the fake image. It looks like it will flip a coin. Depending on the output of flipping a coin, it will decide whether it is real or the fake image. If the discriminator does not have anything to learn now, because the generator has achieved a certain status where it can generate the images like a real image. So now in this situation, what will happen? Because the training is still going on. So the progression poses a problem for convergence of the GAN as a whole. The discriminator feedback gets less meaningful over time. And if GAN continues training past the point when the discriminator is giving completely random feedback. I told you what is the random feedback. Randomly it will, because the 50% accuracy is there now, the discriminator. So random feedback, then generator starts to train on the junk feedback, where the discriminator accuracy is 50%. That means what? The generator has learned almost all the things, but that feedback, through the back propagation, still we are giving. So what this generator will learn? It will learn on the junk feedback. And finally, the quality may collapse. And that is what the mode collapse I was trying to mean here. one example I can show you of the mode collapse. Here, the upper portion of the image, by using some GAN architecture, upper portion, it is 2-3 different models has been taken to distinguish the handwritten digits 0 to 9. But over the time, over the number of iterations, the GAN network, because the generator is now, everything is learned, but still you are giving the feedback, then what will happen? There could be a collapse. So look at the below portion of this slide. All the images looks like a 6. This is what the mode collapse. Another example, the better example I can show you. Just look at for a while the both image, left part and the right part. If you clearly look at the left part, all the images is about some boat only, river with the boat. Now it is trying to generate some real image, and after that it has collapsed. Look at this. This is the collapse situation, left part. This is the green one when will come. This is the collapse part. Look at this. Now it cannot generate so this is the problem, that we have to give the proper solution so that your GAN network should not come across the mode collapse. Whereas the right part, if you look at the picture very clearly, each block is showing the different images. Images of man, images of horses, images of bird. So different images, but still in the left part, the same image was there. What image? Kind of image means the boat with the river. Here the different images, but still in different images also you may get the mode collapse. This is the mode collapse situation that we can have if we are not having the good control on your GAN network. Okay. Now, so obvious question is, you have designed your own model for GAN. Now, how can you measure that? There are, you have gone through the different F1 score, accuracy, sensitivity. There are many things that the different matrices, confusion matrices and all machine learning you must have gone through. But here, these all can be used, but the two very much important matrices out of more than 20 different matrices, we are just discussing the two matrices. One is the IS, that is nothing but the inception score. Inception score is what? If it is being given to you, you can judge the quality of the images. So same thing we are trying to cultivate by using the computer with the help of the inception score. What is that we do? If we look at here, in this PM of y by x, what we are doing? We are using the conditional probability. So we are a conditional label distribution for image x. And here marginal distribution representing the entropy of the variable x. X, you know that what is x and what is y. Okay. Y is the basically label, x that we are getting as the image. Now, what is the basically means the kind of quality that we can measure with the help of these matrices. Similarly, another matrices is the French inception distance. It is basically the version of the inception score only, where we try to find out the difference of the mean of the real distribution and the covariance of the real and the generated distribution. So with these two, we can measure the quality of the images that we are generating through the GAN network. Now the question is, why do we need the different kind of architecture of the GAN network? One architecture is not sufficient. Why? So there are the various reasons. Before that, just look at that. What could be the different variation? If we have gone through some cryptography courses or some other ANN courses, so you can see that we decide number of neurons on each layers, we decide the number of layers of the hidden, and so on. That all depends on the kind of the application requirement. So here also we decide about the number of generator, number of discriminator, the kind of conditional input, the kind of noise level that we are giving, kind of distribution, which distribution that we are using, the kind of density function that we are using. This all will make the variation in architecture of the GAN. Similarly, accordingly, the first you will see only one G and only one D, whereas the output of G is being mixed with the, so this was the very simple GAN network. We call it as the vanilla network, vanilla GAN. Another is the CAT GAN. In the CAT GAN, similarly, the EB GAN, what we are doing from the output of the generator, we give it to the encoder and then decoder. So the layer we have in the discriminator network, the two different encoder has been incorporated. Similarly, in this LAP GAN network, if you look at, it's a hierarchy of the G, means the output of G, it has been given to the another layer of the D and so on. So different requirements is there. So different researchers has designed their own model to get the proper output. Okay. Now, so I was telling you the different various architecture. Reason is to stabilize the training, to avoid the mode collapse. Right now we have seen the mode collapse situation. To accomplish the desired output resolution, means the kind of quality that we wanted to, the generated desired mode of data, conditional setup of preserve, the semantic layout, and so on. Now, just go through the sum of the from I think 5 to 6 slides. I am just trying to show you the sum of the output of the GAN network where we can do something. What we are doing here is in the different epoch, we are trying to improve the quality of the image. That is what we are showing here. Okay. Now, this is the rotation of the character and the thickness of the character. That means as per our desired output, we are designing our network. Now here, if you look at the different GAN, the web, KVAE, AC GAN, DR GAN, on the different epoch 1 and epoch 40 for the digital image, for the different images of the human being and so on. So this all are the different output is being shown by the different researchers. I'm just showing it now. Look at the some of the fantasy. One of my BTech student, why I'm sharing, because it is important to understand that the significance. Somebody asked that. One people, he was very much interested in fashion design and so on. Then he was telling, he just asked that, sir, how it is possible to design the different clothes, different shoes, different songs? Is it 100% creativity? What if I do not have this? Then I ask him, you get a one design, you think of this GAN network and try to generate the different design for the your certificate. He was not successfully completed, but he did many things, and where he could realize that, okay, in fashion designing, people may think of the such kind of the network. So in computer vision, if we'll see what kind of input we are giving and what kind of output we can get. Okay. Now here, this is basically a different African travel mask that we are, and this is being generated by using the GAN network, different GAN networks. Okay. So what are the people are doing? I'm trying to show you. Now here, the bedroom designs, interior designs can be think of the output of your GAN network. Some noise means you just take the one image. From that image, take the noise sample, and from that noise sample, you can generate the many interior design. Here another the fantasy one is what? The vector arithmetic for visual. It is what the first column, if you look, it is the smiling woman. Second one is the neutral woman. So a smiling woman minus neutral woman means we want to extract the smiley characteristics of the woman. and that we want to impose on the neutral map. So you look at this, we may be getting the smiley map. Okay. Now, in the different pose that we can, you take the one pose, and then you can generate the different pose of the single image. The another one is what you have the some leveling you do, and in the ground truth you apply the GAN. Then on the right side you will see, right in the last column, the third column, you'll see the output of the certain GAN network. Okay. Now the photo blending can be done. You look at this, the green field. Here it is the yellow field. Now in yellow field, if you want to take the green field pictures through the photo blending, so this can be done with the GAN network. In the GIS people, they all are taking the images of the river to do the certain study. So this can be done because the satellite image, if you look at it, could be very blurry, could not be the clear, because in different situations, different climate conditions, the GIS pictures may not be having the very good quality. So how can you do with the study and all for the river and all? So that can be done. You can increase the image quality by using the GAN, and then you can clearly see the courses of the river, and so you can do the particular study depending on the situation. Now, this all is related to the image application. The same thing you can do with the natural language processing also. Without wasting the time here, you look at this example. In input, let's say if you are giving that this movie has tight plot and skilled actors. I was listening the very first session lecture, and he was telling the sentiment analysis and all. So there are the multiple process to do it, but the same thing that we can do, we can extract the semantic of the input text. So this movie has the tight plot and skilled actors. So generated text, how awesome the movie is. So this is the input. So this is the part of the NLP that we can do. Okay. Now, another things, the text is being given. From the text, you can get the images. Like this, a small bird has a yellow crown and the white belly. With this description, with a certain noise of a certain noise sample you have taken of the bird, you can generate your own bird, your own figure. Okay. Similarly, the group of people are standing on the beach next to the ocean. You can create a different figure. Similarly, from the different figure to figure and so on. Now, here in security domain, I will take the 5 minutes time to make you understand the security domain, what we are doing. What happens is, as you know that if you want to secure your own system, in many ways you have secured your system, in many ways, but still your system gets hacked. That means what? Hackers is having some different way of doing it. That we genuine coder is not thinking in that way. So can we think of a training where we can generate I will name it like a fake, the output of the generator, which will mimic the adversary attack and will make the this becomes the learning for the discriminator. So what will happen? Ultimately, what we are trying to, we are saying that the discriminator will learn that this fake output of the generator. So in case of the security, it will mimic the concept of the attackers. So adversary attack, it will mimic, and then it will allow you to learn that, the discriminator. So in that way, we can apply the GAN network in the security as well. For example, we can think of the spam filtering, you can think of the computer security, you can think of the biometric recognition. Here, just look at this slide. Here, the 2 parts are there. One is adversary, left part, and the victim B. So what this victim is doing, there is a parameter server. So this victim has downloaded some parameter, and it has its own local network, this network, okay? So with this parameter, and this victim B has learned this data and labeled as A and B, fine? Now it has updated that parameter to this parameter server. Now what this adversary is doing, this is GAN network, I am saying this is GAN network. Now what this adversary will, it will also download some parameters from the parameter server, and now with that it will try to categorize the one image and label as A. It has data labeled as a B and C, but it will say that this data, which looks like a digit 3, which is being categorized as C, is basically a. So what it is saying that though it looks like I have labeled as a C, but in my model, I will make the training so that this will be categorized as A. So now I can learn that how can I make the fool to the particular the legitimate person, and it can attack. So I can learn the different attacks, adversary attack, so that I can make my server more a secured system. Now this is your different the real phishing domain. From the given domain you can generate the different, so you can learn that, means your system can learn that what are the different URL can be generated for phishing attacks. So that can be learned in the security domain by using the GAN network. Now here the last example of the security, the finger vent pattern. What happens is there are many security devices where it uses the biometric parameters to recognize you. But let's say if you are using the finger biometric is now very old. People have started to using the gesture of the finger vein as a biometric features to recognize you as a legitimate person. But now think of when you are healthy, at that time your image has been captured, the vein image has been captured. But you know that over the period of time there could be some disease, and you got some disease in the vein. So next time whenever you are pressing your finger vein, your system, though you are legitimate person, you know that, but the system will not recognize because there is some disease, means that there is some different characteristics of the vein. It could not match with the previous one. So how can we do this? So one way of here is what I can look at this, what we can do. So the very first image you have taken, so you did some image pre-processing, blur enhancement, threshold segment, image de-rising and thinning, and finally you get this picture. And this is what you know, that your system knows about this different dots, the vein structure, which is very clear. Now the healthy persons, the left part, you scan from the left to right, okay? So healthy person finger veins, after pre-processing you get this, your system knows about this. But now the same person, legitimate person, got some disease, the vein disease, and after applying the pre-processing, same pre-processing, image pre-processing steps, we got this output, the fourth picture. So you know that your system will not recognize this, but you are legitimate. So what you can do, this picture you can treat as from this picture you take the noise sample, give it to the GAN, and you make them learn to that with this, if somebody is coming, you can allow them to access the system, because slowly and slowly your GAN network will convert from fourth picture to the second picture, because second one is the real one, and the discriminator knows about this real and the fake image, but this generator slowly and slowly will learn about this. So you can think of generating the image, the fake image, which looks like a real image in this, the recognition system, the finger vein recognition system, the biometric system also, okay? So now you can think of one way is what, they This is not good for the security domain. Yes. So that is what I'm saying. You think now in reverse order. You have to train your biometric system that if some image is coming, this you can treat the fourth image, you can treat as the adversarial attack image. Okay. Now, but your system is aware of that the adversary can get the certain kind of this image in original, and but while training it got the real image, so it can block it. So this concept we can utilize to secure your biometric systems as well. Second, with these features, if we tag with some another biometric features, then your system could be a more secure system. Mind it, there is no system which is 100% secure. There is no system which is secure for the lifetime. Okay? We just wanted to enhance the security, nothing else. Now, so this is different things about the security domain. I will talk a little bit about the medical also. Here you can see the CT scanning we have. But from the CT scanning, the first scanning, you can get some good quality images, or depending on the segment, means we can apply the segmentation to understand the very specific doing the analysis of the very specific portion of the human brain and so on. This can be done using the GAN network. Another you can look at reconstruction is possible, means you know that in MRI and all, more than 150 the images has been captured in the short duration of time, but all the images you can combine together to get the single image. So reconstruction is also possible, re-registration is also possible, classification is also possible. Here in the retina you can see by using retina vessels, but after doing the segmentation you can get the very clear pictures like this. So this becomes very this image will give the much more information to doctor to do the very good diagnosis and all. Here I was telling you, you have the only, let's say, the CT images, but if you want to get some more data, some more critical information, then you cannot ask everybody to get the PET scan, or your model where you want some learning for the PET images, but you don't have that images, you have only CT images. So from the CT images, use the GAN network, generate the PET network, PET images, and finally you can do the machine learning and so on. Something like this here also. Okay, so this all we can do with in the medical images also, where we can fill the gap of the mismatching unavailable data. We can get the certain data aspect. Okay, now here to one of the paper, I'm just giving you the one reference of this paper. This is being published in 2020. Is basically is applying the unsupervised learning to identify benign and malignant lung nodules. Okay, but in this paper what they have done, they have only a data set for the benign. They don't have the data set for the malignant. So how you can do the classification, how you can identify the benign and the malignant. So for this purpose, this paper, they have used the GAN network and they were able to get the accuracy. Look at this accuracy. Accuracy is about 95.32%, sensitivity and specificity 90.78%. Why this data is very much important? Because this author is having the data set for the benign to detect the benign, but it wanted to see that from the images data set of the benign, if you want to find out or to detect the malignancy, then can we use it or not? So look at this. It has used the 1375 data set of the benign nodules only and tested on the malignant nodules. And in that is the beauty of this this work. And the accuracy is 95.32%. Sensitivity is 94.15. Accuracy means is the proportion of the true result. Means जिसको malignant है उसको malignant बोल रहा है, जिसको malignant नहीं है उसको malignant नहीं बोल रहा है. So true positive or true negative, that is the accuracy. It is very high. It's a very good result, 95.32%. Similarly, the specificity is what? It's the ability of a test to correctly identify the people without, जिसको disease नहीं है उसको correctly बोल रहा है no, does not have disease, and that is 94.15. Mind it, this data is for what? It has done the tested on the malignant, but data set was used for the benign nodules. Okay, so this work is this has shown a different way of these researchers to do something more in the medical domain. So with this, I would like to show some of the features that we can think of. The most of the slides, it was basically in the medical image and.
Sir, I have a question from the previous slide.
Yeah, please.
Sir, can you just move to the previous slide? Sir, it means like the model
Which
is being
slide?
trained.
First tell me
Sir,
which
the
slide.
last, the sir, where you have
Yeah.
mentioned about the benign and
Yes,
malignant.
yes. Tell me. Yeah.
Sir, here, the model is the person, the data scientist. For an example, the data scientist is just having the data set containing the benign images, right?
Yes,
And then
yes.
he has applied this GAN network. And GAN network, like generator, has generated the fake images. Fake images means which were like malignant, right?
Hmm.
And then the training process continues, right, sir? Okay, thank you, sir.
Okay. So, but we can apply this concept for generating the audio video. Means some words has been given in the NLP words, and from the words what could be the next word. This is being done in the machine learning level also, but through the GAN also we can get the more accurate result. Creating the graphics design layouts, we can generate the tabular data. So these are the different domain where we can apply, means the NLP, information retrieval. Now people are trying to get the different, because basically the GAN network is unsupervised. It uses the unsupervised learning. Okay, now it is trying to see that whether it is possible to do something in the model to look at the another learning, the strategy like supervised reinforcement and so on. So this is what people are trying, but nothing has come into concrete steps, but research is going on this. So those who are interested, they can think of NLP by using GAN. They can generate the sequences of the statements, or you can think of writing an essay by using the GAN network and so on, because some noise you have given as a text, and now you can think of the statements into paragraph into the essay and so on. So difficult, but possible. So this is all about from my side. I think this is time over. So thank you very much for giving me time. If somebody has some questions, I would like to answer if it is possible.
Yes, any participants have any query?
Yes, sir. Sir, is there any library which is which we need to apply to create this GAN network? I mean,
As I told you, this is basically network. What kind of network? Deep neural network.
deep neural network.
Convolutional
Right.
neural network. So whatever you are using the tool for these two, the same tool will work here. Okay.
Sir, like, is there
Have
any
you done
coding
any
like for
implementation
creating?
have you done any implementation for DNA, CNN,
Yes,
or
sir. CNN. Yes, sir.
so,
NLP also.
So we talked about the architecture where two networks are there, but what is that network? How do we implement that network? You know that.
Yes, sir. Sir, like in the practical, like maybe 3 or 4 months before, like I have done, but by using both the images. I mean, this benign and malignant, by like taking the data set from the Google Kaggle, basically. But now, but as the example given in the slide, with the help of the benign,
You
benign,
can do one thing.
which
I have
line of
given
code?
just a minute. For more detail, what you can do, I have written the author's name and all. Just a minute. This is the very recent paper. IEEE in Access. You can go through this paper. You
Okay.
can get all the answers that you are asking right.
Okay. Thank you, sir. Thank you.
It's a very recent paper in 2020. It has been published in IEEE. Okay.
So please share the PPT link. Yeah. Thank you, sir.
Okay. So thank you very much. And once again, I would like to thanks to Institute. This has given me a chance to interact with you learned people. So thank you very much, sir.
Thank you,
Anything?
sir.
Okay. So
Now,
shall I quit from this session?
yes, sir. Now it is the time of vote of thanks, sir. So wait 1 minute, sir.
Okay.
On the behalf of SSBT CVT Bambhori, I am very much thankful to you, sir, as you have accepted our invitation from your hectic schedule, and you have delivered very nice session to all the participants, sir. And also, I am very much thankful to Dr. Girish Patnaik, sir. He have recommended you. He is a professor of our head of computer department in SSBT, and because of his recommendation, it is possible to communicate with you, sir. Only. Finally, I would like to give thanks to all participants also. Thank you very much, sir. Thank you, sir.
Thank you very much.
Yes, sir. Yes, sir. Now it's a time to take a lunch break. You finish your lunch before 2:50. We will join with the same link at 2:50 for the next session. Thank you. Thank you, sir.
Welcome, sir.
Yes, sir.